Hi, everyone. Good morning, good afternoon, good evening, depending on where you're joining us from all around the world. Thanks for being here. You joined us for another monthly edition of Networking Insiders. And the goal of Networking Insiders is that we bring folks from Cisco and from our ecosystem partners to talk to you guys about the very latest in networking. So I'm Drew Betts. I'm a networking solutions engineer at Cisco focused on wireless. And today's topic is the latest in Wi-Fi. So I think it's very cool to see. We're going to be talking about outdoor Wi-Fi 7. We made a big splash and announcement at Cisco Live Las Vegas, so we'll dive into those new access points. We also want to give a preview to Wi-Fi 8. So we're really excited to see what the future looks like as well. And like I said, we do this webinar with our ecosystem partners. So I'm so excited to have Hamina with us to talk about their site survey tools, what we can do to integrate these new products, and just the importance of having a Cisco wireless network correctly deployed with a proper site survey. So before I get into things, we always get asked one question, and that question is, where are the slides? Where's the recording? So I'm happy to say that our Networking Insiders program now has a YouTube channel. So you're welcome to search on Google, easy enough, ask your favorite LLM to summarize the content. Whatever works best for you, there's hours of content that you can go back and watch. But the good news is this is now saved forever on the internet for us to go back and reference in the future. So there's two things every YouTuber often says. They want two things. They want blank and blank. And you guys are welcome to do either of those. I'll leave it totally up to you. So our speakers today, or I should say our networking insiders today, are these three gentlemen here. I'm going to start with number 3 and work our way back. And Jerome Henry is a teacher at heart. I first approached Jerome or interacted with Jerome 17 years ago when I first started at Cisco. And he was teaching the basics of Wi-Fi, I think, at that time, or maybe I can't remember the exact topic. But Jerome has such an amazing way of translating really complex topics into ones that are relevant, meaningful, and in a way that you understand and you want to understand. He builds that trusted teacher portfolio really well. So Jerome, thank you so much for joining us. Now, Jerry, I'm so excited to have Jerry because he's an evangelist of surveys. He's an evangelist of tech and troubleshooting and the ability to make your network work the best it's ever worked, no matter what vendor your wireless is from. So Jerry, thank you so much for joining us. And then Nicholas, well, Nick is an advocate of the customer. Nick, originally, when I first met him, he was in the field as a sales SE, just like myself. And Nick has carried that customer advocacy throughout his career at Cisco. So he's probably the most customer-focused product manager that I've seen in wireless at Cisco. I'm so happy to have you here too, Nick. So with all that said, these gentlemen are going to walk us through the latest in Wi-Fi 7 as well as the future of Wi-Fi 8. So to get us started, Nicholas, I'm going to hand it over to you, sir. Over to you.
Thanks a lot, Drew.
Of course.
I appreciate that introduction. You know what? I'm just going to go ahead and jump right into it, start sharing my slides, and let's get the show on the road.
You got it. And there's two words that I really can't stand on a webinar, which is next slide. So I'm empowering everybody to share their own slides. So we'll let Nick get all set up here.
Okay. Just move myself here. Well, hey everybody, as mentioned, my name is Nick Sviateke. We're going to be talking about what's new in outdoor Wi-Fi. I will now go to the next slide. But before we jump into outdoor Wi-Fi, yeah, come on. Before we jump into that, I did insert one slide because I think this is super important for all of you who love dealing with Cisco Wireless. We did launch a new tool that I want to give a shout out, apchannels.cisco.com. It's kind of like the old tool where you can see which countries work for, which AP models, but there's a refinement. You can click on the AP type and you can now see what channels are available from what software version across the different bands, both on 9800 and Meraki. Just a quick little shout out. It's a tool that I know a lot of you have been waiting for, and this is now live. So I just wanted to give this a shout out on apchannels.cisco.com, and it's publicly available. Anyways, with that little promo over with, I do see at least one clapping emoji there. Let's talk about outdoor Wi-Fi. It's interesting, right? Sometimes people ask me, "Wait, do we still need outdoor Wi-Fi? Hasn't cellular solved all of that?" And I laugh a little bit and start asking them, "Hey, which of your devices have cellular modems, and what about all the others?" And More recently, I was discussing with some friends over dinner, and you were like, "Well, is this a car? Or is this a computer?" Right? If we look at this image, all these these cars are recording data and they're uploading them, and now we're all set at charging stations waiting for our cars to charge. There's a bunch of data going there, right? And a lot of these cars, they like to connect to Wi-Fi if they can, and there's a lot of entertainment. There's a lot of data going through these cars. So actually, the need for outdoor Wi-Fi is going up, right? The need for capacity in specific areas outdoor has actually gone up over the past few years, maybe contrary to what a lot of people think. Now, of course, there's still, the good old point-to-point, point-to-multipoint. There's a lot of you guys' networks that run on a backbone that is wireless network, kind of a mesh topology or stuff like that, and that's of course still relevant, and we still build for that. Another area, that I do want to kind of give a quick little data point on is, we've been part of the Bottle Rock, which is a festival in Napa Valley in California for quite some time now. And I just wanted to show some pretty interesting stats, right? Over 3 days, we saw, 58,000 unique clients on this wireless network, right? It was, based on our large public venue access point, the stadium access point, if you will, on 6 gigahertz as well. So, 48% of the clients were on 6 gigahertz, powered by open roaming, and drove a ton of traffic, right? Offloading the cellular networking, providing a good customer experience, good end user experience right there. So, outdoor Wi-Fi is absolutely still relevant, and we see a ton of traffic going through it. Of course, open roaming helps the onboarding, big part of it, but I wanted to share this data with you guys out there. Now, if we look at kind of the portfolio from the Cisco side, as Drew mentioned, we did have a new announcement here at Cisco Live in June, 9177, which I'm going to spend most of the time on in this quick little presentation here. But of course, wanted to get a little bit of an overview of the overall portfolio. We still have the 9163E on the kind of left end here. Great access point, 2x2, external antennas, solid outdoor Wi-Fi, does 6 gig as well where that's available. We have our industrial and ruggedized line. The IW line, still really good product. We have the 77 that I'm going to touch upon in just a moment. And as I mentioned, we have the 79F, which is outdoor as well. So for stadiums, for really long throws, we do have that hyper-directional product as well. So a little bit on every shelf when it comes to outdoor and rugged products from Cisco. Now, let's talk about the 77, because that's what I'm most excited about. We announced 3 models, the I, the D, and the E. So the I model, of course, internal omnidirectional antennas. The D model, internal directional antennas, giving you that built-in patch antenna for directional coverage. And yes, there is still an E version with external antennas. We know some of you love that, so of course we made that available as well, and we've also introduced 2 new antennas, which I'll touch upon a little later. So there's a lot of goodness that we announced here at Cisco Live. And yeah, the images here are not to scale. Somebody asked, so I had to put this in here. Now, what are kind of the key highlights here of the 77? Well, first of all, it is a tri-band access point. It is 4x4, so we can do 2.4, we can do 5 gigahertz, and we can do 6 gigahertz. 4 spatial streams, 3 bands, so that's 12 spatial streams. Interestingly enough, we can also, for areas where 6 gigahertz is not yet available, such as Europe, we can actually run this access point in a 255 mode. So we can convert the 6 gigahertz radio into a second 5 gigahertz radio. That means you can do fun things as, do backhaul on one 5 gig link and serve clients on the other. You can serve 2 different areas with 5 gig off the same access point. So we've really thought about, those places where 6 gig is not yet available, how can you get the most value, from this access point, at day one. Where possible, we've made it compatible with both the old Catalyst and the existing Meraki mounting brackets. So again, something we really spend a lot of time on. AFC support, of course, we're going to talk about that in just a second. But at launch, going to have support for the US and Canada, so you can absolutely do 6 gig outdoors. We have native integration with Cisco Curb, so ultra reliable wireless backhaul. Right, we'll touch upon that just a little later, but that's their launch. There's Meraki mesh and there's Catalyst mesh right out of the gate for these platforms. Finally, yep, SFP Plus on these access points, just like the 9124 that a lot of you know and love. We have continued making fiber an option, so you can run SFP Plus or run SFP for that sake directly to the access point. And we do also have the ability to power the access point via DC power. So for those long runs, far away from a PoE switch, you can absolutely use this access point. You can light it up with fiber. And yeah, just mandatory, unified licensing like the rest of our Wi-Fi 7 portfolio. Orderable now, shipping in September. So on the topic of AFC, standard power, we are talking outdoor Wi-Fi here. A lot of you probably know this. Some of you do not. If you're in the US or Canada, you can absolutely use 6 gigahertz outdoors. You connect it to an AFC, and from a Cisco product perspective, that's one knob, and you get 6 gigahertz channels. Now, for the rest of the world, it's a little more complicated. The short version is for Europe, it's kind of under review, no exact timelines. The UK is further ahead, potentially opening it up towards the end of this calendar year. And we are involved in trials in places like Japan that are also looking into how can 6 gigahertz, the 6 gig bands be expanded to outdoor use across the globe. So in short, if you're in US and Canada, no issues, go use 6 gig right out of the box. Other places, you need to look into your local regulations and figure out what's available. And if you're not able to use it, well, we have the dual 5 gig mode for you to use. Zooming in a little bit more on the access points here, I don't want to read out all the specs per se. We talked about the I, internal Omni, the D, built-in patch antenna, about 72 by 72 beam width here. All the details are, of course, in the data sheets, but this gives you a rough idea of how you would use this access point. One of the cool things we did is in Wi-Fi 6E, actually, in the indoor portfolio, we introduced accelerometers so that you can see the tilt of your access point. Now for the 77, this is, we kind of brought that through. So for the 77D and the I, we can actually measure the tilt of the access point itself. And for the E version, we actually extended this so the accelerometer is now in the antenna element. So I'll show you one in just a moment, but the patch antenna now actually has the accelerometer. So again, you can verify if your install has been installed as you planned it, right? Did the installers install that patch antenna with a negative 30-degree tilt or not? Just from the comfort of your chair, or did somebody bump into your access point, which happens. Oh yeah, copper port is now 10 gig. We talked about SFP plus. These are IP67. Again, it's everything that you would kind of expect from a high-end access point from Cisco. It is really the spiritual successor to the 9124 here. Something I get a lot when I talk about these is, hey, that looks a lot like the 79F, our stadium access point. Yes, it does. It is quite a lot smaller. So, I took a photo here on my living room floor the other day. The 79F, our stadium large public venue access point, is, substantial in size, smaller than the older one. But here, just in comparison with the 74 and the 77 here, you can see that the 77 is actually quite a lot smaller. And, we're pretty happy with how much heft we packed into to this platform here. In terms of the antenna portfolio, as I mentioned, we launched 2 new antennas. The directional patch antenna, so 88 by 40, so nice asymmetrical patch antenna here, 8 dBi gain. And as I mentioned, the accelerometer is actually in the antenna element itself instead of the access point, which is great. And similarly, if you want omnidirectional coverage, you have an external access point, the 77E. We have a new bell or dome antenna, which is tri-band. You can also do dual 5. Yeah, ready to go. So this is tri-band and, of course, omnidirectional here. Few quick highlights here. As we always spend a lot of time thinking about how we can make this easy for you guys and your installers. Everything on the back of the antenna, it's color coded, right? So those of you who know, let's say a good old 9120, if you have a dual band antenna, it's orange. If it's dual band with SIA, or self-identifying antennas, it's purple. Same thing here, we've color coded the connectors, both on the cable side and on the antenna side, with both colors that, yes, are colorblind safe, we checked, and a letter, so A, B, C, D, etc. And for the keen-eyed amongst you, we introduced some new colors for 5 and 6 gigahertz. But again, key thing here, we really tried to make it as easy as possible for the installers to take a cable, see, oh, this is, purple goes on purple, magenta goes on magenta, etc. As I mentioned, this access point does support our ultra-reliable wireless backhaul. It's a bit of a mouthful. But in short, this means that you can now have one access point serving up not just regular 802.11 clients, but our industrially grown proprietary technology that gives you high-speed roaming. It gives you extra resiliency. We can send frames over 2 different paths, so multipath transmission and reception. All of that is on the 77 from launch. So don't just think of this as a quote unquote outdoor access point. Start to think of this as kind of a lightweight industrial access point where we can support the guy with his iPad at a loading dock, whilst you also have a fast roaming robot driving around, your lumber yard or your warehouse. All of this can be supported on just one access point at launch. Also, and this has been a long outstanding ask, so I wanted to give it a call out here. Shout out, Catalyst Center does now finally have the support for outdoor areas, kind of like Prime did. And some of the features that you know and love from Prime, visualizing mesh links, all that good stuff is now on Catalyst Center, so kind of a perfect companion for the 9177. Of course, this access point is supported both on the controllers in Catalyst Center and on Meraki. I should make sure to mention that. And with that, you know what? This is available in playing tools like Hamina today. So I'm going to hand it over to Jerry to give us a demo of what Hamina looks like today and hopefully show us a bit of the 77. Before I do that, I will give one call out because that mistake is on us. In Hamina and other planning tools, there is a little bit of a mistake in the 77D data. We're working on fixing that, but that's on us, so don't hold it against them. Yeah, and with that, I'm going to pass it over to Jerry.
Awesome. Appreciate it, Nicholas. Thank you for the nice warm transfer there. Let me get my screen share going here. And for those folks on the call that are not familiar with Hamina, yeah, I'm Jerry Ola. I'm over at Hamina Wireless here. I'll give you just a real quick overview of what we do here at Hamina. And really what we're all about is providing tools for folks that are designing, deploying, managing wireless networks. So kind of one of our centerpiece products here is going to be the Hamina Planner. That's a browser-based network planning application. And I'll do some demos for you here to show off some of the stuff that Nicholas was talking about in the Hamina application for the planning side. But also one of the things I wanted to focus on is some innovation on the site survey side, and in particular on the Wi-Fi 7 front with the site survey piece. So why don't we start with that side of it, and then I'll show you some other things here in the planner application. So I'm going to see if I can get my screen share going here and show you what this looks like. So I've got my iPhone here. Notice how what is missing is I don't have any cables connected. I also don't have any straps or anything like that for carrying around any kind of Wi-Fi measurement devices. So this is the one of the latest and greatest as far as Hamina goes. We've got the ability now to do these site surveys without needing any cables or straps or anything like that, even to do something like a Wi-Fi 7 survey, Wi-Fi 6. So what I've got here is the Hamina Clip. And this is our new Wi-Fi measurement device. We also have its big brother, the Nomad. Both of those are Wi-Fi 7 capable, but I wanted to specifically show you the Clip because what I can do here is I can just tap the connect button here, and just by having the Clip near the device that I'm surveying with, in this case it's just an older iPhone, but it'll work with an iPad, that kind of stuff as well. And now I can do my site surveys using the device here. So I'm just going to show you the on-site application here. It's already doing some active testing of the network that I'm connected to. I can see here that I'm connected on 6 gigahertz. So this is using the radio in my survey device to do that active testing, which means if we need to test a Wi-Fi 7 network and we want to see the true Wi-Fi 7 performance of the network, as long as our survey device is a Wi-Fi 7 capable iPhone or iPad, we can now use that device to do the active testing, while all the passive measurements are coming from the Clip device. And no cables or straps or anything. You just clip this onto a belt or a pocket, and you're ready to start testing the network, checking for other competing signals that might be overlapping or interfering. It's also going to give you recommendations about, are you using industry best practices with the network configuration? And here you can see in my environment, I need to work on my Wi-Fi design. Clearly, I don't have enough secondary coverage here. If you can't see the APs behind me, these are all clearly for show. I do not have these powered up, so it's telling me I don't have good secondary signal, but I do have very good primary signal. So that's a good indication of, we don't have enough overlap between our cells. Could be leading to roaming problems, drop calls, things like that if you're supporting those kind of things in your environment. But lots of other analysis here that we can do with this information. I can go into like a widescreen view, and we can see all sorts of other stuff here to show this kind of information here. So you can see these are all the details here in my environment. Here's 6 gigahertz, 5 gigahertz, how many clients are connected on each channel, the health of each channel of like utilization. If we go to like 2.4, you can see my environment is actually pretty boring, given though, again, I've got all these APs sitting behind me. There's not a whole lot actually going on in my environment right now. But yes, then the big thing here is we can do all this site survey with that data, right? So I can go in here and I can pull up my projects and I can do a site survey. And I do have a project already pulled up here, but let's go ahead and put that aside for right now. And let's look at the planner application here to show you some of this. So one of the other things I want to show is the Hamina Live integration that we have directly into things like Catalyst Center, into Meraki, to be able to pull this rich detail into Hamina, or vice versa, go from Hamina into those platforms. So we can help with both sides of that. So I've got a project already pulled up here, and since this webinar is particularly focused on Wi-Fi 7 and outdoors, I thought it'd be fun to maybe do a little design together here for an outdoor environment. And I've got this environment modeled up. If anybody's been to Cisco's offices in North Carolina and RTP, you might recognize this kind of aerial view of the space and buildings and parking lot here. But yeah, if we take like some of those new access points that Nicholas was just showing off, and we want to play around with some design, I'm just going to remove these off of here for a second, and we're going to look at a few different things. So I've already modeled up this environment. When it comes to some of the trees and foliage, you can do a lot more detail than this, but generally this is going to be enough for if we're just trying to design for maybe coverage for the parking lot and some of these outdoor areas. You get like a basketball court back here. So if we want to make sure we've got coverage in all those kind of areas, this is usually going to get us where we need to be. Obviously, if you need to cover much longer distance and do point-to-point links and things like that, we're going to probably need to model some other things into that environment with like terrain and elevation and stuff like that, which we can also add some of those kind of details in there as well if needed. But in this case, let's just grab some of these new fancy 9177 APs, and you can see we've got these in Hamina. I can filter down to just showing like the 3 different 9177 models that Nicholas was just showing in his slides. And we can see here, if we just start with the indoor integrated antenna, or not indoor, integrated antenna here, omnidirectional, we place that maybe on the side of the building here. We can see what that coverage is going to look like with the default configurations on 6 gigahertz. If we can utilize, if we're in an area where we can utilize 6 gigahertz and things like standard power, we can adjust those kind of parameters in here to represent those and model those in here. We also have an AFC function built into Hamina. So if we input like the GPS coordinates of where this site is actually located, it will actually go out to a real AFC provider, provide those values of what we can actually set our power levels to ensure that we can actually use those power levels in those environments. Especially if you're in the U.S. or in Canada or in Mexico, where we have those AFC coordination services that we can use in our design for standard power planning. But yeah, here using like these integrated antennas, we can kind of see what that looks like. Just mounting these ceiling mounted, or in this case, be like wall L mounted You can change those mount types to represent that. If we want to put these like directly on the wall of the building and face those out, or put it on some type of a bracket, we can simulate those kind of scenarios as well to kind of rotate the face of the access point to simulate those things. But once we've maybe done our design, let me just do a couple more things here. Let's do like we'll do like a 9177D, and I'm gonna put this one over here on like this side of the building. We're gonna try to cover this parking lot out here, and kind of just run through a quick scenario. So let's say we put this out here. Again, I'm showing on 6 gigahertz, and we can see what that coverage kind of looks like. But maybe if we're wanting to get connectivity and good coverage all the way to this end of the parking lot, obviously that's not going to be a great user experience. And we can even model in here like a Wi-Fi 7 capable client. We've got different types of clients that we can simulate in here. So let's simulate like the latest and greatest iPhone that's 6 gigahertz capable Wi-Fi 7. And maybe they come out of the building here and we kind of simulate, what that user experience is going to look like when they get across the parking lot here. And this thing actually will cover plenty far. You can see it's not a great user experience. We're all the way down to -75. So not going to be a great user experience, but it is able to actually cover all the way with that 6 gigahertz coverage all the way out to the edge of the parking lot, but not really provide the greatest user experience. So let's see if we can improve that. I'm just going to throw another access point in here. Maybe we do like a 9177. And we'll put this up maybe a little bit higher here at like 14 feet or so. And let's try and put one somewhere maybe out here. Maybe we've got a light pole or something that we can attach it to out here. And, then we got to figure out how we're going to get a cable out there. But maybe we want to explore doing something with like mesh, right? So we could see, okay, could we mesh this off of that one that's on the building there? And here it's looking like that's a little too far out based on our current configurations and everything to get a good like mesh backhaul, so we can figure out, okay, where would we need to put that AP to get a proper like backhaul on this. So you can kind of play around with those different knobs here. And also if we're able to use something like standard power, then we can look at increasing our radio transmit power as well, depending on what our AFC provider tells us we can actually use. Oh, also, I did not, this is the main thing I didn't do, was I did not switch the mesh radio to use that 6 gigahertz for its backhaul. So right now it's actually using 5 gigahertz on there, but now that I've turned up the power on 6 gigahertz and we've adjusted that, look at what we can get on the backhaul here. So with the current configuration, even just using a 40 megahertz wide channel with this AP out here in the parking lot, you can see we can get plenty of throughput on that backhaul and really good signal. And then if we go and model our client back in here, we can see what that user experience ends up looking like as they move across the parking lot here. And what kind of connectivity they're going to get. And yeah, see, there's plenty going on in chat there. Any questions or anything come up that we should address at this point before I change topics?
No, I think you're good. One curious question about importing Ekahau surveys. Is that something possible?
Not officially supported
Okay.
on the Hamina side,
Okay.
but what we do officially support on the Hamina side is the ability to import and export to multiple APIs, as well as this
Excellent.
open intent file format. So if I go to import here, you can see we do have this from file, which is an open standard. So if you convert those echo files into something like an open intent format, then yeah, we will absolutely ingest those into Hamina. Whether it's right now it's simulation only, but very soon we're going to be expanding that open intent. They've updated the schema now to also support survey data, so that's going to be coming very soon as well, where we will import that from any platform that you did like a survey from. As long as it's in that open intent schema format, you can import those projects into Hamina.
Very cool. That's great. I
And
love
that's
that mesh example you gave, Jerry. That was very cool to see. Yeah.
nice.
Yeah.
And that's a good segue on like the import export side of things to the last topic that I wanted to cover was the live integration piece, where we can like, let's say once we've finished our design here, we can either export this information right from Hamina into something like Catalyst Center, into something like Cisco Meraki, with Meraki. We've got the nice, API integration piece where all you have to do is plug in your Meraki dashboard API key. And now that enables the ability for us to push and pull information. So I could deploy the site right into Meraki so you don't have to manually replicate that or into Catalyst Center. But then also what we can do is leverage the live component here into Hamina. So just to show you what this looks like and actually give you a little preview here of something that we've been working on that we've just released here to the public is the ability to now have this integration right into Meraki for like a one-click button to actually pulling all that information from Meraki into Hamina. So if you want to do some live analysis, live troubleshooting with the Hamina platform, you can actually import this data. So I've got my Meraki account pulled up here. You can see there's some different knobs in here than you're probably used to seeing of like open this project in Hamina or import to Hamina. So if I don't even have this particular site here, which I've got our Hamina lab selected, I can say import that site directly into Hamina, and it will actually go with just a single click, pull in all that data from Meraki into Hamina. So in this case, just a single click now. This is using this Chrome extension to pull all this data in. And so you can see by just having this Chrome extension in and by being logged into like my Meraki account and my Hamina account, it allows those two platforms to very easily talk to each other. And now all of this kind of work is happening behind the scenes, right, to build up this model into Hamina. So a few seconds ago, Hamina didn't know anything about this site, and now it's just built this environment and model of this site from the data that it got out of Meraki, including these live APs, right? So when I click on this AP, this is an actual live deployed AP. This is actually a site over in Europe. I can see all the details about how each of these radios are configured. We got some 9166s over there. And let's just see if we've got any clients. Yeah, we've got a bunch of clients connected to the network. So if I select a particular client, it's going to show me details about that client. It's going to immediately start doing some active testing of that client. And then if I want to seamlessly go back from Hamina into the Meraki side, I've got a little button here that'll take me right back to the Meraki dashboard. And the cool part about this is you can see it takes me and zooms right into that client that I was just testing in the Hamina side and gives me all the historical context. So the Hamina live side will give you the live analysis, the live troubleshooting tools, and then going back into the Meraki side, we get some additional context about what's been happening with that client for the last day, the last week. So we can seamlessly go between the two platforms. I can also do the same thing where if we go to like the wireless side here and I go to like the overview of this particular site and then we go down to, like the client level kind of details, we can then zoom in from there to see that. So we can go from either side of this. So if I go to like the client side, you'll see we'll have this same kind of detail here where I have the little Hamina button now where I can click on that particular client. Same thing, it'll pull up that project. It'll select that same client that we were just looking at in the Meraki side. And now we're doing all sorts of connectivity testing with that client, getting all the active information about that client. This one actually happens to be running the Orb agent on this client. So that even gives us some additional insights than just what we get from the Meraki side of more from the infrastructure side. We also get from the user side of it, what does their experience look like? So we actually get the downlink and uplink RSSIs, so both directions to see if there's any kind of mismatches there. It does a speed test, all these kind of active tests that we can now run against these clients to give us more insight for troubleshooting. All right. That is pretty much everything I wanted to cover with the time that I had here, unless there's any other questions in the chat that I should cover before
Yeah,
we.
Jerry, we've got a lot waiting for you. So I think the best
Oh
thing
boy.
is, how about everybody? Thank you so much for submitting your questions. And Jerry will spend some time answering those for you because I think there's some great questions in there for you, man.
Cool.
Awesome.
Sounds
Well,
good.
thank you so much. This was excellent. I know I learned a lot. I was particularly impressed by those mesh links. I thought that was super cool. There's so much there. So now, why don't we switch gears? And we talked a lot about the current state. How can I make my Wi-Fi 7 network amazing, right? But let's think about the future state, because at Cisco, we're always invested in future protocols, future specs, making sure that your voice is heard in standards bodies and establishing the future. And with that, we have Jerome Henry here. And Jerome, I'll hand it over to you to give us a little preview on Wi-Fi 8.
Thank you, Drew,
Of
and thank
course.
you. And you're right to say I'm right now at the IEEE, where the 802.11bn standard is being designed. We're also talking about Wi-Fi 9, security, AI, ML, IoT, a bunch of stuff. And as Drew says, we are invested in bringing a voice, guys. We have about 25 people at Cisco in this meeting, participating and trying to look into what is going to come next. So, Wi-Fi 8 is not there yet, right? It's 2028, at best. So probably somewhere next year you'll have people saying, "Oh, we are pre-Wi-Fi 8," but the reality is 2028. So Wi-Fi 7 is still there. But we're at the stage where we know what the standard is going to be doing. We have an idea of where it's going to go and where it's going to stop, and where next generation in a couple of years, 5, 6 years, will take from. And to me, being in the enterprise world, there are about two main features which are really, really interesting. And, a couple of others are kind of supporting the big guys. But, in all, in this future generation, there are about 18 different things that have been designed. So if you are at home, there is much also that will be useful for your home, talking to your home access point. But for the enterprise, two big guys, what we call SMD and DB. And if you remember what we did in Wi-Fi 7, we did MLO, right? You remember that's the main thing where we try to have a connection to two physical APs, and that left us in a state of mid satisfaction, because we wanted to do more, and we always have to refrain from doing more because there are physical limitations into what the technology or the physics can do at the time we designed these things. And one of the things that we wanted to solve in Wi-Fi 7 but couldn't is this idea of channel assignments. You saw what Jared was doing was super cool, where you move the access points and you have these mesh links that form, you change the power, you increase the backholding, all that is super cool. And when you design your network, of course, you're going to have RRM that's going to be dynamically setting your channel number and the channel width to the best of whatever your building is going to need. But this has one limitation in the standard, which is that you cannot really change the channel width very dynamically. I mean, you can, RM we could configure it to do it, but it would be disruptive, because in 802.11, we say if your AP changes its channel width, well, then it's not the same network anymore. So per the standard, you need to disconnect, and then you need to reconnect. So every time we change the channel width, it has some disruption risk for your clients. So in Wi-Fi 7, we said, well, there is not much we can do there because it's in the standard, but we've been fighting, among engineers, and we found a solution for Wi-Fi 8, and that's this DBE, dynamic bandwidth expansion, that you see here. And what this does is, the idea is that you set your channel width as usual, so you let RM do the job for you, maybe. And then what happens is that the APs can talk to each other. So you may have this AP in this meeting room, for example, that you set to 80 megahertz. Well, that's a waste of bandwidth, because most of the time the AP is not, nobody's connected there. There's maybe a couple of sensors, one WebEx station, and that's it. So you set it to 40 megahertz, right? But then, 20 people walk in, and then suddenly 40 megahertz is not enough anymore. So what DBE does is it allows the APs to talk to each other and have this AP in the meeting room say, wow, guys, you know what? My channel utilization is increasing. We need to have more bandwidth. And that AP is going to be able to dynamically increase its bandwidth as, channel utilization increases, so that, when you have 20 people in the room, you increase to 80 megahertz, 160, whatever you need. And the APs around, in the neighborhood will know that, so that they don't try, to overstep on that AP. What is very cool is that, of course, we do RM. So, right, we know that this communication can happen between access points, or it can happen via some controller, controller on site, in the cloud, etc. The speed at which we're talking, adaptation here is a few seconds. So we have plenty of time to discuss between APs. And that, allows us to have a very smart adaptation of the channel width and the channel plan as people move about. So that is, very interesting. What, of course, was the risk is what I said at the beginning, right? If you change your bandwidth, the clients might be disconnected because per, standard, it's not the same network anymore. But the way we do it here is actually smart. The old clients, I'm going to say Wi-Fi 7 old and before, Wi-Fi 6 and those guys, they're not going to see that change. What happens is that the APs are going to use a Wi-Fi 8 extension to say, well, Wi-Fi 8 guys here, I'm increasing from 40 to 80, 160, you name it. Which means that for the older guys, Wi-Fi 7 or 6, they can still use that regular bandwidth, while the Wi-Fi 8 guys can increase the bandwidth to something bigger. Now, the risk that we're facing here is to say, well, but then that means that everybody's using that 40 megahertz channel that we have commonly. So, maybe we have a bit of an overload there. But that's where now what I was telling you is that there are some other features which are pretty cool because they are complementing this feature. And one of them is this one, non-primary channel access, where here, not only the AP can say, hey guys, we're expanding to 80 megahertz or 160 megahertz, but it can also say, hey, Wi-Fi 8 guys, if you want to talk, let's move up to this upper parts of the channel, which means that now you have the older guys, Wi-Fi 7 and before, that still have a 40 megahertz channel on the primary channel just like before, but the Wi-Fi 8 guys, they have not only a wider bandwidth, but they can also be moved outside of the way of the primary channel so that the old guys are not, disrupted by this communication from the Wi-Fi 8 guys. So that makes that, everybody gets more bandwidth. So it's very efficient. And then of course, people walk out of the meeting room, the bandwidth utilization decreases and, the AP slowly goes back down to 14 megahertz. So for me, this is, super exciting feature because it's automatic. So it's very flexible. I know being Cisco, we know how to do RM, right? We've been doing it for 20 plus years. So, the subtlety here is to do it well, right? Where you have a design where you anticipate the need, you're not reactive, but you are not jumpy. If there are a bunch of people walk by the meeting room, you don't want to, change your channel too fast. So, we have a bunch of smart guys working on this engineering there to make sure that it works for your meeting room, but also, train station, Tokyo train station, where, 1,000 people walk out of the train at the same time. It's going to be working very nice. So DB, that's the first big guy, which I think is very interesting. Another one is this SMD that you saw on the first slide. And here, to get you what this is about, I need to go back to this MLO structure. Back when we started designing MLO, that was in 2018, we thought, hey, it's super cool if you can have 2 or more links, to an access point. And back then in our dreams, we were saying, well, even maybe, you roam and you connect one AP, one AP1, and then you connect your other link to AP2. So that means that you are like Tarzan, you're jumping from AP to AP. That would be cool. But then, the laws of physics, hit us back in the face, and we realized it was not possible for, many reasons. One thing is if you send traffic from your phone on 2 links, at some point these packets need to be reassembled somewhere. So if it's in the same AP body, physical device AP, well, that is very easy. But if these APs are on different bodies, different structures, then you have to design how you talk between the APs. That becomes super complicated. So with the time we had in Wi-Fi 7, the complexity of that communication, we couldn't make it work, which means that today, Wi-Fi 7 MLO is super cool, but it's connecting to one single physical access point. And that means that if you roam from one AP to the other, what you have to do, you may have your 2 links, connected, or 3 links, I don't know. But then at some point, you'll need to detach one of these links to go and scan, find another AP. And when you find that AP2 that you like, then you need to go back to the AP1 and say, sorry, I loved you, we had a great life, but I'm moving on to AP2. And then, boom, you drop the connection, and then you reestablish the connection to AP2. That takes time. It's a bit disruptive. I mean, we have FT, fast transition 11R, which allows you to pass context fast. But, this is not still stopping the fact that at some point the client tells AP1, I loved you, but I don't love you anymore. So anything you have, dump it, because I'm jumping off. And then it goes to AP2 where you have to restart the communication. And we're saying, this last instant of that communication to AP1 to AP2 is going to be creating some glitches. Maybe not if you're web browsing, but if you're in a robot in the factory and that you're doing real-time traffic, if you have AR/VR, these very demanding real-time applications, there may be something there. So what we do in Wi-Fi 8 is to say, well, really the idea here is to hang your hat on these two APs, right? So why don't we detach the concept of AP from the physical body of the access point? And that's what we do. And that means that when you connect in a Wi-Fi 8 domain to this SMD, seamless mobility domain, you're going to connect to an access point, but that access point is not going to be just a device radio. It's going to be a sort of virtual entity that we call the SMD AP. And that AP, for now, may be on AP1 on the left side, but it doesn't have to be here. You're not connected and attached, to AP1 as a, forever love story. You're attached really to this AP-SMD. And what that means is that you can still do the MLO stuff to this AP on the left side, everything is fine. But then if you want to roam to the next AP, to AP2, you still have to go scan all that stuff. But at some point you find AP2. And then what you do is that you come back and you tell AP1, hey, I found that AP2, and what I want to do is to move my session there. And then what will happen is that AP1 and AP2 are going to start talking to each other. And as they talk to each other, they are going to be agreeing on a sort of timing of the transition, which means that they'll be able to say, hey, you know what? Mr. Clients, I'm going to send you the next 5 packets. And then from packet 6 and up, AP2 is going to relay me. So they count down together, 4, 3, 2, 1, and bam, at that time at 0, the transition happens, which means that both the clients and the APs know exactly when the traffic is going to stop through AP1 and when it's going to continue through AP2. So obviously, with FT, all that stuff, you pass all the connection session, all the keys, etc., to AP2. But you see the timing of that transition is also done so that, the interruption we say is going to be in theory 0. I don't want to say 0 because, real world, you may have some processing of the client to decide that you're changing radio. There is a dwell time and jump time on the radio internally, some stuff like that, which means that, we say it's going to take, a couple of milliseconds for you to be able to jump from one AP to the other. So, of course, if you are seeing a classroom and you're listening to a teacher, SMD is not super useful. But if you are like, us, at Cisco, where essentially you get in the office in the morning, you have a laptop, and then you go talk to people, you're on the phone on WebEx all day long, and then you walk, this is where it starts, being useful. And we have, countless cases of, people are architects or devices transmitting data at high rate. It has to be real time because there is some AI there that's guiding a robot and stuff like that. And in that case, really that transition needs to be fast. So DBE is super cool. SMD is very efficient. What is interesting here is this idea of make before break. It's funny how we keep saying that the more the technology advances, the more the cellular technology tries to borrow from Wi-Fi, and the more the Wi-Fi people, the 802.11 people, stop borrowing techniques that were proven efficient in the cellular domain. So this is another one where of course in the cellular world you have a control channel where your cell tower is going to tell you exactly when you switch. We cannot do that in Wi-Fi because we don't have a control channel, but we definitely have this communication between the AP and the client. What is interesting there is this idea of overhead. Now, I like the question you asked, Jeremy, because every time we transmit data between APs and clients, we're consuming airtime for data, but everything we do is going to also have a cost if we have some overhead for the management frames. And what is super interesting, and what I don't have a lot of time to cover here, is that the guys in the 802.11bn, which is the IEEE basis for this Wi-Fi 8 standard, were completely paranoid about any airtime consumption. So there are things that we could do exactly as Eric says over the VS, over the first AP, say, well, I found AP2 over scanning, talk to that guy so we don't consume too much airtime. There's also guys who told us, yeah, but over the space, over the air is faster because I'm already connected, so I can maybe go faster. So we also have features where we can do it over the air. But everything that was designed in Wi-Fi 8 looked into every single bit that was sent, and we're saying, when you talk about this neighboring AP, do you need to send all that? Maybe not. When people probe, do you need to respond to all the probes? Maybe not. If you know someone else is probing, maybe you can delay the probe because you have a beacon coming. So we have a constant optimization of the airtime. So here, the measurements we've done about how much more this is going to consume actually show that if you compare to a Wi-Fi 6 scenario, for example, where you have one link and you transition, you will have some discovery time, you have some attachment time, and then we have some losses because some packets arrived, were sent, not received because you moved, and so on. And what we see is that the battery effect of this SMD roaming is actually pretty null. It counterbalances the losses that we see today in a Wi-Fi 6 or 7 scenario with this overhead of those losses and misses that you have there. So although there are some packets, because the management frames are compacter, they are more compact, and because we try to be paranoid into how many of those we want to exchange, we reduce the loss as well, which means that in the end, the consumption is going to be less. Battery-wise, it's less as well. So this is fairly exciting. There are a few other things going on. For example, there is one that I like a lot, but this is very geeky. It's MAPC, multi-AP coordination. And the idea here is to have multiple APs near to each other, coordinating their efforts to try to make things more efficient. So for example, imagine you have two APs on the same channel, OBSS, and they're serving different clients. In the Wi-Fi 8, this obsession with this efficiency, what the design MAPC to do in that scenario is to have the APs talk to each other and say, what kind of clients do you have? Do you have guys doing voice, data, background? And the AP may say, well, I may have some voice traffic going there, and they are going to dynamically assign the TX up between them so that the guy who has more time sensitive traffic can have a bit more bandwidth than the guy having less sensitive traffic, sharing the same channel. They also have, some very cool feature where we say, imagine that you have a wide deployment and you want to increase the power to a single client. Well, we can do it with beamforming today. Okay, super cool. But if we design this multiple AP coordination, and now we have the clocks in the APs that are so accurate to nanosecond level that they can talk and synchronize their action, to very high accuracy level, they say, well, you can share a TX up if you want to, but maybe you can also beamform together, which means that maybe you can increase the channel bandwidth to that client that is at the edge of the network. So when you have the scenario that Jerry was telling us about, where you get to the end of this parking lot where you're very far away, maybe these two APs can work together if there is nothing better to do to send all this traffic to that guy so that you maintain a good connectivity as you are far away. So that is the main thing. There are plenty of forms, of this MAPC. So I'm expecting that in the early 2028, and maybe at the end of 2027, you'll start hearing people say, "Oh yeah, we're doing MAPC," and they will tell you something, and someone else say, "Oh, I'm also doing MAPC," and tell you doing something else. It's a container, it's a multi-AP coordination. You coordinate to do what? You can do a lot of stuff, if you can work together. To me, this is very geeky. In the real world implementation, how often you need to be informed to the guy dead of the parking lot. I know Jerry always park at the end of the parking because he likes to walk, but it's kind of a corner case of where you really need that stuff. Same, sharing TX up. Hopefully your neighboring APs are not on the same channel, right? So you should not need to share TX up. But if you have very high density, you need to do it. It may happen to Cisco Live, that kind of stuff. You can use the step. Well, so it may be useful. You probably won't see it very used every day, but that's very nice. So that is in a short a view of what happens in this scenario. What we are aiming to do there with this MAPC is to say, we are aiming to solve these last micro drops that you may have. You know that with Wi-Fi 6, with 6 gigahertz, we improve the conditions a lot. Then with Wi-Fi 7, you know, redundancy on MLO, we reduce this kind of a perfect storm when there is a lot of a talk and then suddenly everybody collides. You know, you have two links now, so you can recover faster. So we reduce the amount of time that happens. With Wi-Fi 8, we say, well, with this MAPC, we are going to reduce even more so that, you know, we are going to this 999, so on, so that, you know, we almost get to a point where there's a guarantee of delivery. That is the idea. I was telling you that, you know, it's too early again because we are still Wi-Fi 7. We still have plenty of years of Wi-Fi 7. But, you know, hey, we're working on Wi-Fi 8 because, you know, we need to be 5 years ahead of the curve in the IEEE because, you know, it takes a lot of time to design the standard, you know, fight with different interests to understand, you know, how we solve all the use cases. We are, to be true, you know, already talking about Wi-Fi 9 as a sort of science fiction thing. But, you know, Wi-Fi 8 is coming in 2 years. And that's where I can stop, Drew.
Thank you so much, Jerome. As we know, there's always a next generation. There's always something new to look forward to. But that was an awesome summary and update. Thank you so much. There's lots of cool things that I was hoping would make it. That sounds like it's getting in there. So good to hear. And thank you, sir.
Thank you.
So lastly, team, I have a bonus brief speaker for you from our ecosystem team, and that's Charlie. So Charlie, I want to hand it over to you for just a moment to help shut us down for the day. Thank you, sir.
Absolutely. Sounds good. Yeah, no problem. Thanks so much to all the speakers here today. Really great stuff. And really appreciate the partnership that we have with Hamina. So my name is Charlie Dwyer. I am on our networking app marketplace team and sort of hold the relationships between our extended network of ecosystem partners like Hamina here. If all of you, saw a lot of the marketing that we pushed out for this event, you may have noticed that we had a giveaway to this as well that we wanted to sort of put a cherry on top for. So here are the criteria for the eligibility. So, we're looking for customers or accounts that are based here in the United States. You cannot be a public sector account. I'm sorry. And how you would be eligible for this or to sign up for it is to sign up for a demo of the Hamina solution via this QR code that'll take you to the the Cisco networking app marketplace here. Yeah, so we'll leave this up here for a couple of seconds. If you want to scan that, click on that, go ahead and register for your demo. We will be updating this. We're going to allow kind of like a week or two for this to fully pass so that we can get up to 30 registrants for this. But the code that you'll be receiving from us, if you are a winner of this, will take you to sort of a landing page where you've got the option to choose from 6 different items. Drum roll on those too, but you're looking at a pretty cool fire pit, maybe perhaps for your back patio, that iconic Polaroid camera you wish you always had. Some new Apple EarPods for you golfers out there, a handy dandy golf scope that's going through. Maybe for a few of you that have been really tight at your computer working all the week, we've got a massage gun. And for all of you show lovers, there'll be an Apple TV there as well. So go ahead and scan that QR code if you want to jump up for a demo and get registered for one of those items. And if you are kind of curious, and there we go, Drew, nice. I didn't have to say the non-phrase there.
That's it.
But if you've got some more curiosity too and are looking to see how Cisco's platform also extends your capabilities, here's sort of a quick link to the actual landing page for the marketplace. We have over 350 turnkey applications. These are all verified. These are all solving customer use cases that you might have in your environment and integrate in with every single part of our portfolio. So go ahead, explore that. We just updated the page, so you've got a really great view on how we're sort of providing all of this extended capability. And we're really grateful for you coming and attending today. So thank you so much. And with that, I think we can close it out.
Thank you, everybody, for joining us. Take care, and we'll see you next month.